trying to manipulate it and use it in the front end aspect of it. And yeah, that was it for us right now. Let me just see if I can get.
I think you guys are working primarily on the front end, which you moved to Streamlit. Earlier, it was, I remember, React.js is something you were trying. And
yeah,
now
before it was the React.
Yeah.
Let me just see if I can run the Streamlit so that we can.
Sure.
I was having some problems with the graphical part of Streamlit.
And there are folks who are working on the backend side as well, as in the UI is good, but let's also talk about what you guys are doing on the backend in terms of the models and the analytics. So yeah, let's first look at the dashboard. Maybe while it starts, let's also discuss about the models that you're using. So you guys are planning to use the DeepQN, right?
Yeah, we're planning. Wait, I think it might just be. Yeah, we're planning in using the DeepQN model.
And they also have other kinds of models. For example, they also have like PPO and there are some other reinforcement learning, policy gradient, and whatnot. So you're planning to start with just DQN, and then you will see from there, right?
Yeah.
Okay. Fair enough.
Let me just. I think there might be some small problem. Because we're having some problems running it.
Yeah, maybe you can come back, go to the different group, and while you run, we can come back to you, right? So just to summarize, you guys are focusing on the dashboard. Then you are also trying to figure out the PyTorch as in the setup. And in terms of the interpretability, or what's the problem statement eventually you are focusing on? Is it interpretability or trying different models?
We were first we were trying to build the front end aspect of it where we would be able to use different models, and not only DQN, but they also had like PPO and like Actor Critic. And those different models in it. And then from there, we were considering in using some of the interpretability graphicals used in the previous paper, like the heat map and the Q values over time given different characteristics.
Okay.
So that was
okay. So if I think about the enhancement on top of what was done before, earlier those guys used DQN. So you will be also doing other models like PPO and policy gradient that you just mentioned. So that will be the value add, and maybe we'll see if we can add more number of features. Okay. Yeah. So these two. I mean, let's keep this end goal in mind, and can do the things and align the timelines accordingly.
Yeah.
Cool. Maybe the next group can talk about their ideas and their progress while we come back to John.
Hi, Aaron.
Hi.
I'll share my screen. Yeah, basically we are using different data. So for now, this is the case of the Apple. We're using Tally to build our feature, and we add several new features on it.
Perfect.
Like
yeah.
You can say, yeah, it's we add ATR and the money flow index. Some new that try to run this in this base model, and then we keep doing that. So there's one thing Nora and me find that we evaluate our model performance, and the accuracy is, I mean, it's too perfect. Everything is like for this one, for confusion metrics, the accuracy is 1, F1 score 1, and over back testing, it's like a perfect prediction, right?
Yeah.
So I think
what you guys are using is you are using
it's a random forest.
Yeah, you should try to remove couple of features and see whether this remains the same. So maybe what's happening is the output that you're trying to predict is very close to one of the features or some of the features, right? And that's why it's causing things to be very similar. So for example, the output that we are trying to predict here is the long term, whether the long term or whatever 60 days horizon is more than 5 year, right? So that is probably encapsulated in one of the features already. So try to remove some of the features and see what happens. You get my point?
Okay. Yeah. So we also for the stock market, we also adjust the strategy. We adjust the like for determine the short and the long. We use the 50
Got
MA
it.
50 and MA 200. They
Right.
usually use those parameters in stock market, but it's different with the crypto. And
Right.
also,
Mhm.
and also Astra are doing the Amazon and the Israel, and Nora are doing the Microsoft. I can, Astra, can you share your screen?
Yeah, so the question that you asked about like the total or overall prediction being very perfect. So here you're using Talib, right? Talib SMA
Yeah.
you're using for the dependent variable, right? So that
Mhm.
might already be one of the independent variables. So your dependent and independent variable are very similar, which is causing the accuracy to be close to 1. Get my point?
Okay. Add on it. So for the training stuff, like if I change it to decision tree, or like for now we're using random forest classifier. However, if I change it to decision tree and stuff, it's all it's all lead to the same result. And it's like the back end, the back testing, I still have the same result if I use the the same kind of strategy. Like, yeah, I don't know why is that. Is that because we use a lot of feature engineering?
So I think
So in the end,
I think maybe you have included some features which are very close to the dependent variable. And irrespective
yeah,
of the model that you're using, it's causing or leading to accuracy close to 1. So might have to try removing some of the features and see how it looks like.
yeah, okay.
Yeah.
Yeah, Astra.
Yeah, I'll share my screen with what I did with Amazon. So essentially we did the same thing with other features. We added features like ATR, MACD, and I also got similar results, or we encountered the same problem, which is probably for the same reasons.
Yeah.
We got an almost perfect result. So we will definitely look into getting rid of some of the features and see how it reacts with it. So I did the same thing with Ethereum as well, just to see how it would react. And we also use different time periods of the data set as well. And again, we got the same similar results with this as well.
Yeah, so I think there are 2 ways you can solve this or handle this. One is where you're defining your dependent variable when you're doing Talib SMA 60 minus SMA 40. Just define it in a different way where you say, let's say, hey, if the price goes up, and there can be different ways of defining it, but just to put it simple, you have to check whether the price will go up or down tomorrow, right? So you can define it without using all these Talib libraries and just see if the price next day is going up or down. So up 0, up 1 and down 0. And all the features should be till today, right? That these are all the features, all the indicators which are till today, and tomorrow we are trying to guess or figure out whether the price will go up or down. So keep it very simple, the dependent variable, and that's something you can try. So that's one way of handling this high accuracy. The second way would be just remove some of the features. So what might be happening is 1 or 2 of these features are very close to the dependent variable. So your dependent and independent variable, there is not much difference. So if you try to remove those independent variables, then you might actually have decent enough accuracy. So there's a lot of similarity in what you're trying to predict and what are the features you're using to predict. That's my understanding from here.
It sounds great. Thank you.
I also have one question. So if it's the kind of feature we adding in, it's kind of can predict it that well. So what is the reason that we have to remove the feature? Like if it can predict like accuracy like 100 or something.
Yeah, so the accuracy is 100. I mean, I might have to check the entire details, but my understanding is that the way you're defining your dependent variable, right? SMA 60 minus SMA whatever 5 or 10 is, right? You're taking a simple moving average of long-term minus short-term, right? And that that simple moving average is also one of your features, right? So you're trying to predict a simple moving average using simple moving average, then it will be a really like the accuracy would be much higher, right? So you have to either modify your dependent variable. It should not be a simple moving average or something like that, or you might have to remove one or two features which are very similar to your dependent variable, something that you're trying to predict. Make sense? Yeah. So yeah, I mean, let's take a step back and think about like the bigger picture of this project. So I guess all of you guys are on the right track. You're trying different models, trying different variables and asset classes. So yeah, keep doing that. But yeah, let's define the problem statement in a better way so that you guys don't have this accuracy of 1, because that's something will not lead us to anywhere. Yeah. Great. Any other comments on this, or we're good? Cool.
Yeah, I'm going to share my screen. We try to incorporate the local volatility model, the hypothetical volatility model into our current code, and this is so we allow the volatility to change rather to be constant. And now the results show, and we generate 15,000 data, because if we use less data points, the models will perform worse, like compared before when we use BSS model.
Yeah.
So you can see the price compared to the previous one. It's like the previous one is more like this, but now it's already more like concentrated around this point. Volatility is more screwed.
Yeah, this looks a little strange to me. Can you go up? Price chart.
Screwed, so the
No,
correlation matrix, I think.
Yeah, before we go into this, let's see the price chart once more.
The prices.
Yeah, so price. And do you have the axis numbers? Because I don't see the numbers there on the axis.
Numbers? You mean the descriptive statistic?
What I'm saying is you showed a chart of price versus, so if you go down, first chart, which was very different. Yeah, this one. So what's the numbers on the axis, do you know?
I'm not sure. I only generate the data points and run the plots as before. So the seed is the same as before. You see, it's no big change. We only change the volatility formula and generate the data points compared with the previous BSM model, because it's only hypothetical. If we want to construct a real local volatility model, we need access to the historical data. And now we only use the simulated data. So
okay, so what you're doing is you are using the simulated data from how you're simulating this sigma, and can you show me the equations? So I'm curious about.
This is how it's simulated. It's no difference between compare the previous file, but we change the formula here. It's only hypothetical because real local volatility model requires historical data, but now we only simulate here, use random.
Okay,
So
I mean, let's move ahead. We'll come back to this. Let's see your results.
okay, so it's like correlation is no different. So the plot metric show here, so like the nonlinear characteristic is more obvious, I would say. So the moneyness is still the most important. And let me see here. Here.
Yeah.
So for all the models, like MLP, I remember. Okay, MLP is, what is it? MLP and KNN also exhibit poor performance compared to BSSM, because only before like MLP and KNN is better, like now they perform well.
Yeah, I expected MLP to behave better. Can you increase the data points? And also, I'm not sure. Now let's go back to the equation that you were showing. So I'm not sure whether the right equation, because you're not even calibrating using the historical data. So where did you get that equation from? Is that like local wall equation?
What?
So the formula that you were showing in the code.
Okay. Here?
Yes. This is your Black-Scholes and
Oh no, it is a local volatility, hypothetical volatility, local volatility model. And I plot the heat map as before. Do you want? You can have a look.
I wanted to understand. So I understand the call price. I wanted to understand how you're getting all these sigma, alpha, and beta for this local wall. So
You mean
have,
where I get the data point?
no, where you're getting these variables. So in this,
The variables are the same, like the before. So this is the parameters, and this is the variables. This is the original BSM, original formula. I change the, I add the log, log to this, and add a thing to this. So it's not big difference. It's only a proposed hypothetical local volatility model. So what I think is like, if we want to incorporate a real local volatility model, we need historical data. So then our next step may be like collecting the historical data to construct a local volatility surface.
Yeah, so try Yahoo Finance. Yahoo Finance also has option historical volume. So if you just search on Google for option historical volume on Yahoo Finance, it should have the historical data across all the moneyness and different maturities. So you can just get the data from there and try to calibrate a wall surface on local wall and see whether you can plug that in here, because this doesn't seem to be very correct to me. Although this is fine, I mean, having a simulated data, but try getting the actual data and see how it looks like.
Okay.
Yeah. So the source would be Yahoo Finance. There you can get there's Python code using which you can extract the data of let's say S&P 500 option, take different moneyness and different time to maturity, and then that's something you can use to calibrate local vol. You might find a couple of code already there on the internet to get the local vol using Yahoo Finance data, and then you try to calibrate, and then you might see better results.
Okay.
Okay. Cool. Yeah, but I think we are going in the right direction in this. So yeah, good work. Cool. Anything else from you guys? If nothing, we can maybe go back to John and have a quick discussion.
I just wanted to know if Michael had any comments. I mean, have you started getting involved in this project, Michael?
Yeah, so I'm catching up on the materials, and I reviewed the code that was previously done. We met prior to this meeting.
Okay.
Discuss the updates.
So
John?
I'm having a little bit of problem actually loading the graph. I
No, I
think
mean,
it has to
maybe
do.
you can share the screenshot in the LinkedIn group that we have, or
Yeah.
you
So
can maybe-
like
yeah.
we were able to get the form running,
Mhm.
but the graphical part is not actually running. I think it's because
Yeah, let's maybe you can share a screenshot, or maybe there are tools to just create a video and share it with people. So your call. Maybe if you want to share a screenshot, you can share it with me. You want to create a video, or maybe we can discuss in the next call, which I guess is 15 days from now. So it's better to just share a screenshot with me so that I can comment or something.
yeah, I'll try to we'll try to have something by next week. Then how about that? And we'll email it to you, or we'll share it on the GitHub repo, because I think there is a problem with the actual graphical part, because when I run it,
Yeah. So what you can do is, once it is working, just take a screenshot and put it on the link. Yeah.
Okay.
sounds good.
I was just going to say, like, with our other teammate Bach, he was actually able to get it to run on his VS code. So whenever we meet with him again, we can ask him to take a screenshot, and then we can send that in the LinkedIn for you to review.
Yeah, works for me.
Yeah.
Okay.
Did Andrew, were you able to show the previous one that we did on Visual Studio?
Oh yeah, here. If you give me
Okay.
1 second, I can pull up that code. I actually didn't. I wasn't able to show it last week. Hariam wasn't able to make
Oh,
it,
I
but
see. Like I can just pull it up over here. So yeah,
okay.
so this is
that,
this is another one that we had built using the using the React and
Mhm.
that library. Let me just run an instance.
Let me see and understand the code. So everything is in React and the backend is in Python, right? And you're
Yeah.
using trading environment from Finarl.
Exactly, yeah. So this is another one that we had built previously. Oh, wait a second. This might be the wrong one. Let me just is it here? No, one second. Recent ones. Let me just double check if it's on. It should be on there. Not sure. Yeah, it should be this one. Let me just run the initial. But yeah, this one should be working, I think. Let me just double check if we're getting the data. Actually, this is not this one. Hold on a second. Let me just double open.
If you think it will take time, you can just share the screenshot and we can discuss. But yeah, let's do a last attempt.
Because this one was a little bit more interactive that we had built.
Yeah, I mean, what's your choice of the dashboard? Is it the Streamlit one or React? What do you think would be better?
It was going to be the Streamlit one, but we created one on React just for prior to that, because it was that's how we began processing it. It was on React. After that, we decided to go Streamlit because it was going to be a little bit more difficult to use it on React. Let me just open it.
Yeah, so I think if you have decided that you guys will be working on Streamlit, let's stick to that and focus on like getting the backend even more robust, right? So the idea is could be, yeah, I mean, if you think that the Streamlit is easier, we can have the first draft of the dashboard and focus our energy on the backend, because that is the more interesting part of the project where we can get more stories and more analysis done, right?
Okay, yeah.
But I'll leave it with you in case I guess there are a couple of folks who might be comfortable with React. React might be easy to, let's say, if you want to extend it, have multiple tabs and make it more fancy. It's easily extendable. Streamlit might have its own limitation. If you want to add tabs or multiple kind of charts, you might not be able to do it. So I'll leave the decision with you, whatever you think is easier. But the idea should be that we need to have multiple. So the key problem statement, like multiple models and multiple features, is what we need to look into.
Yeah, we're gonna start looking more towards the back end to
Yeah,
do
but
that.
this front end looks pretty good, right? So
Yeah.
in case you think you can add or modify it easily, add more number of, let's say, text boxes, drop downs for different models and for features of different models. Even extending this one would be pretty good, right? And the advantage of React is that it can be easily extended and it can be made, you can enhance it in a much better way compared to Streamlit. Streamlit has its limitations.
Yeah, well, yeah, there is some limitations on the graphical part for the neural network in the Streamlit, since they don't actually have one. We would have to try to build our own on that side. So we're still discussing and seeing how it goes, but we'll keep you updated, and we'll send you the Streamlit.
So this looks good. I think the folks before you, the project that they did, I think they used Dash, and the dashboard was very similar to this. So